Okay, so what we're going to talk about today is still rational expressions, but we're making them a little bit more complex. We're definitely stepping it up to Algebra 2 today. And I'm going to show you two different methods. Okay, so the first method is to simplify the numerator slash denominator then divide. And the second method is multiply by what would be the least common denominator top and bottom. And you'll understand what I mean once I do a problem. Okay, so I'm going to take a very simplistic example without any variables, and I'm going to show you what I mean both methods. So let's say I have 3/4 plus a half all over 6/5 minus 7/12. So I'm going to show you both methods. So the first method tells us simplify on top of the fraction bar, simplify below the fraction bar, and then divide those two. What does that look like? So on top, if I have 3/4 plus a half, in order to simplify those, in order to add those, don't you agree we need a common denominator? So this is going to be the same as 3/4 plus 2/4. Do you agree? And then in the denominator, 6/5 minus, sorry, this should be 5/6. Let's make this 5/6. So in the denominator, we have 5/6 minus 7/12. Again, we need a common denominator. So this is going to be 10/12 minus 7/12. We keep going with the simplification of the numerator and denominator, or top of fraction bar minus bottom of fraction bar. So we're going to get 5/4, then our fraction bar, and we will have 3/12. So method one was simplify on top of the fraction bar, simplify below the fraction bar, then divide, right? Doesn't that long fraction bar mean division? So this is saying 5/4 divided by 3/12. And when we're dividing fractions, what's that rule? Keep, change, flip, right? So now we have 5/4 times 12/3.
Can we simplify 3/12?
Yeah, you can at any point simplify the 3/12. It's all going to work out the same. So 4 goes into 12 how many times? 3 times. What's 3 over 3? 1. So then we're going to have 5 times 1, which is 5. All right, so that was the first method, the longer method. All right, the second method Now, don't write this down. But if I have a over b, right? Or let's use some real numbers so it makes more sense to you. If I have 3/4, actually, I'm going to have something, I'm keeping it real simple so it makes perfect sense to you. If I have a half and I multiply the numerator and denominator by the same number, say 2, I get 2/4, right? 2/4 is the same as a half, right? If I were to have multiplied it by 10, top and bottom, that's 10/20ths, which is the same as a half. Anytime you have a fraction, if I multiply top and bottom by the same number, am I changing its value? I'm not changing its value, I'm just representing it in a different way, right? So anytime you have a fraction, as long as you multiply the numerator and the denominator, right, above the fraction bar and below the fraction bar by the same number, we're not really changing anything. We're just representing it in a different costume. That's really all it is. So that's the idea I'm going with the second method, even though it looks a lot more different. So what this is saying, let's go back to that same problem. 3/4 plus a half, big fraction bar, 5/6 minus 7/12. Despite everything, how confusing this looks, there is that long fraction bar, right? So this is a fraction. This is the top of the fraction. This is the bottom of a fraction. So in this method, I'm going to multiply by the same number, top and bottom. Because if you take a fraction and you multiply above the fraction bar and below the fraction bar by the same number, are you really changing its value? You're not, right? So that's what we're going to do here. But what number are we going to choose? You're going to look at all of the denominators. And you're going to choose what would be the common denominator for all of the denominators. So 4, 2, 6, 12. What is the common denominator for 4, 2, 6, 12? 12. So what's going to happen is we are going to multiply the bottom of the fraction bar by 12 and on top of the fraction bar by 12. But now that 12 needs to get distributed in, right? Because there's that plus sign. So this is going to be 12 times 3/4 plus 12 times a half over 12 times 5/6 minus 12 times 7/12. And now we simplify. 4 goes into 12, right? When you're multiplying, you could cross simplify. 4 goes into 12 3 times. 2 goes into 12 6 times. 6 goes into 12 2 times. 12 goes into 12 1 time. So what are we left with? We are left with 3 times 3, which is 9. 6 times 1, which is 6. 2 times 5 is 10. 1 times 7 is 7. Keep going. 9 plus 6 is 15. 10 minus 7 is 3. 15 divided by 3 is 5. Did we get the answer, the same answer both ways we did it? Yeah. All right, so now are we ready to bring the algebra into this with variables and stuff? All right, let's do this. Do another one. 2 over x plus 3 over xy, big fraction bar, 3 over x squared plus 1 over 5. Are we ready? Okay, so I'm going to stick with the second method for now on. I'm going to stick with the second method. So the second method, I see my big fraction bar, right? So can I multiply the same thing on top of the fraction bar, on the bottom of the fraction bar, and we're still good? That's what we're going to do. But what am I going to decide? How am I going to decide what to multiply by? You're going to look at all the denominators and choose the common denominator. So what's the common denominator for x, xy, x squared, and 5? What would be the common denominator? Layla?
5x squared y.
You got it, 5x squared y. So we're going to multiply below the fraction bar by 5x squared y and above the fraction bar by 5x squared y. Now that 5x squared y gets multiplied by everything inside the parentheses, right? We have to sort of distribute that in. So this is going to be 5x squared y times 2 over x plus 5x squared y times 3 over xy over 5x squared y times 3 over x squared plus 5x squared y times 1 over 5. And now we simplify. That x cancels, 1x and 1y cancels, the whole x squared cancels, and the 5 cancels. So now this brings us to 10xy plus 15x over 3y, no, not 3y, sorry, 15y plus x squared y. Is everybody up to this part now? So I know that in the numerator, I can pull out a 5x, right? And in the denominator, I can pull out a y. But if I pull out a 5x in the numerator and I pull out a y in the denominator, will anything cancel? No. Since nothing will cancel, do I have to do that? No. If you want to do it, is that okay? Yes. If you do not know if things will cancel, should you do that? Yes. But I know things won't cancel, so we are going to leave it like this. Are we ready for the next one? Okay, same idea. We're going to multiply above the fraction bar and below the fraction bar by the same thing. But before I do that, I am going to factor all of my denominators. So we are x plus 5, x minus 5. So do we agree we should be multiplying by an x plus 5, x minus 5? Yeah, let's do that. Okay, and when we do that, for the first fraction on top, doesn't the whole denominator cancel? So then we're just left with 2x. Then for the second fraction on top, the x minus 5's cancel, so we're left with 5x plus 25. Is everybody okay with me just sort of doing this from here to here in my head, not writing it all out? Is anybody lost by me doing that? Okay, great. In our denominator, the quantity of x plus 5 cancels for the first fraction, so then we're going to have 4x minus 20. And in the second fraction, the whole denominator cancels out, so we're just left with 3x. We combine our like terms, we're going to have 7x plus 25 over 7x minus 20. Can I cancel out those 7x's? No. No, good. Is there anything else I can do? No. No, so we stop here. Okay, this next one is a good one to know. This next one is a very good one to know. And before we start doing this problem, I want to talk about it.
So like if you like have to solve this problem, do you just have to like flip the numerator and the denominator?
So that's what I was going to talk about. The most common thought process here is to take this and put it in the denominator and take this and put it in the numerator. But no, there's a big difference right here. The x is raised to the negative third power and the y is raised to the negative third power. Is that plus sign raised to the negative third power? No. So this is not the same as, I don't know, all right, this is not the same as this. If this were written, meaning the whole expression gets raised to the negative first power, then you're going to flip it to the bottom. But this is saying just the x has the negative third power. This is just the y has the negative third power. That is not the same. This is also not the same as that's also not the same, because are you allowed to distribute that exponent once there's a plus sign? No. So are these the same thing? Absolutely not. So are we allowed just to move the numerator to the denominator and the denominator to the numerator? Is that allowed? No, that's not allowed. So then if that's not allowed, what are we doing? Because that's what most students want to do. Yeah.
I had an idea, but never mind. I'm good.
Why? I like ideas even if they're wrong. I'd rather you think and be wrong.
I think you could multiply by. No, that won't work at all. Cause like I just didn't think about it, so I heard it. So it didn't work at all.
Okay. Tejas?
Multiply by like x cubed.
Multiplied by an x cubed. Multiplied by an x cubed. No, that's not going to help us, because when you multiply by an x cubed, what happens is you add the exponents, so then you're just left with exponents of 0, which is just 1, right? That's not going to help us because we still need the x's and y's. Okay.
X to the negative third is
Yes. Yes, x over the negative third. This is a fraction. Isn't this 1 over x cubed? And isn't this 1 over y cubed? Then we do our big fraction bar, and this is 1 over x plus 1 over y. And then Kai nailed it. Once we do this, then we just do that whole fraction thing we were doing before. I know, Kai. I'm so proud of you.
Thank you, Miss Applebottom.
Aw, nobody's ever thanked me before. Okay. So now this is back to what we were doing. Now we're going to choose what would be our common denominator. Isn't it x cubed, y cubed? So now we're going to multiply everything by x cubed, y cubed. right, here the x cubes, well, I don't want to cross it out. But in the first one, the x cubes cancel. So we're just left with y cubed. In the second one, the y cubes cancel, so we're just left with x cubed. In the denominator, we are going to be left with x to the second, y to the third. And then we're going to be left with x to the third, y to the second. Did I mess that up or are we good? I think we're good. We're not done. Bill?
Should we factor the denominator?
Good. We can factor out that denominator. What can I pull out in that denominator? We can pull out an x squared and what else?
Y squared.
Yep, we're going to pull out an x squared, y squared. And then we're going to be left with y plus x. Do we agree? What about the numerator? Danny?
We just do sum of cubes.
Yeah, it is sum of cubes. It is sum of cubes. So in sum of cubes, we're going to have y plus x, and then y squared plus xy plus x squared. And what happens? The y plus x's cancel. Oh, sorry, there should have been a minus here. Nobody caught that? I did what you guys do. And then this is as far as we can go. So we have y squared minus xy plus x squared all over x squared, y squared. Okay, I'm going to give you one to try by yourself, then we'll do a doozy. Are we ready? So you all try this next one by yourself. This is not the doozy. The doozy is yet to come. Are we ready? All right, somebody tell me, what did you get? What did you get? Danny?
I got x minus 1 over x plus 2.
Did anybody get anything different? How many people got x minus 1 over x plus 2? Good, you all win. It was right. Does anybody want to see me do it? You're good? You say you're good, but then you look so scared.
Yeah, I just back to draw in the beginning.
Oh, okay. That's all right. All right, are we ready for the doozy? The doozies of all doozies. Well, for this lesson anyway. You need a lot of room. So like if you have like this much left in your paper, start a new sheet.
What is this? Yo, what is this?
Oh my god.
What?
Are you ready for fun? So I'll let you write it all down. Are we ready? Did we all write it down? Yes, we're ready? Okay. So what we want to do is we're going to use that same process of multiplying top and bottom by the same thing. We're just going to sort of piecemeal this. So what that means is I can't just sort of conquer this problem in one-stop shop. So I'm going to break things off, and I'm going to look for like fraction over fraction. So I'm starting here. And then I'm going to go sort of off to the side of my paper on scrap paper, and I'm going to have 1 over 2 minus 1 over 2 minus x. And this is still that whole idea of something on top, fraction bar, something on the bottom, right? It's still that same idea. So what I'm going to do is that same process we've been doing, but this time I only have one denominator. So what am I going to multiply everything by? 2 minus x. I'm going to multiply top of the fraction bar by 2 minus x, bottom of fraction bar by 2 minus x. So we're going to have 2 minus x on the bottom, 2 minus x on top. And where does that bring us? That brings us to, on top of the fraction bar, 2 minus x. And on the bottom of the fraction bar, isn't this going to first be 2 times 2 minus x? Which I distribute that, and that's going to be 4 minus 2x. But then what happens with the 2 minus x's for the second part of this? They cancel, so what am I left with? Just minus 1. Anybody lost with how I got from here to here? Okay, so now let's simplify that. This is going to be 2 minus x over 3 minus 2x. Now what I'm going to do is I'm going to take this and I'm going to sub it in for that box that I had just made. So now I'm going to rewrite the whole thing all over again. So now we are 2 minus 1 over 2 minus 1 over 2 minus, but now instead of the box, what am I going to write? 2 minus x over 3 minus 2x. Okay, are we ready? So now what we're going to do is we are going to now take this. And I'm going to work on the side over here. This is going to be 1 over. Are you guys all okay if I distribute in that negative? Well, we could just leave it out. 2 minus x over 3 minus 2x. It's fine. We could leave it just like that. This time, what am I going to multiply bottom of fraction bar and above fraction bar by? What should I multiply this time?
3 minus 2.
3 minus 2x, you got it. So then I'm going to do 3 minus 2x on the bottom, 3 minus 2x on top. So we have 3 minus 2x in our numerator. In our denominator, I'm going to sort of distribute in that 2. So this is going to be 6 minus 4x. But then when the 3 minus 2x's cancel here, what am I distributing in this time? Just a -1. Just a -1 now. So this is going to be -2 plus x. Combine our like terms. So now we are 3 minus 2x over 4 minus 3x. And what am I going to do? I'm going to take this and I'm going to sub it in for that box. Is everyone caught up to me? Can I sub it in now? Anybody still writing down the process? Okay, so now we're going back and subbing in. So when we go back and sub in, I'm going to have 2 minus 1 over 2 minus, but now I'm subbing in the box, right? So this is going to be 3 minus 2x over 4 minus 3x. What am I going to do now? Take this box. So we have 1 over 2 minus 3 minus 2x over 4 minus 3x. What am I multiplying by this time? What am I going to multiply top and bottom by this time?
4 minus 3x.
You got it, 4 minus 3x. So much work. So now this time we're going to get 4 minus 3x over, I'm going to distribute in that too, 8 minus 6x. But now, once again, those 4 minus 3x's cancel, so I have to distribute in that negative. So it's going to be a -3 plus 2x, which is going to give us 4 minus 3x over 5 minus 4x. And what do? Take this and sub it into our box. All right, so now we're down to 2 minus 4 minus 3x over 5 minus 4x. This is where we're at now. Can I multiply 5 minus 4x everywhere. Good, Tori. Why no? You're right. Why no? Good. It's not that stacked fraction, right? It's not that stacked fraction. It's not 2 over this whole thing. This is just saying 2 minus a fraction, right? This could be like 2 minus 1/3, right? Now this is just simply subtraction. When we get it down to just simply something minus something else, what do we have to create? A common denominator and subtract. So at this point, there's no more stacking. There's no more sort of getting rid of that denominator. Now we have to create a common denominator. Do we all agree that common denominator is 5 minus 4x? So now we're going to have 5 minus 4x minus 5 minus 4x. So the second fraction stays the same because it already has that denominator. The first fraction, we're going to multiply top and bottom by 5 minus 4x, which gives us 10 minus 8x over 5 minus 4x. And now we keep our denominator, and we have 10 minus 8x. We need to distribute in that negative, so minus 4 plus 3x. So now we're going to have 6 minus 5x all over 5 minus 4x. There's nothing else we can do there, so we stop. Aw, thanks, Kai. All right, we are done.